So step one here is we've started DB Browser for SQLite. And now we have to construct some tables and fields. So step one, whenever we want to work with a backend data model, and it doesn't matter whether it's SQL or Mongo, which is document collections and NoSQL, or whether it's Firebase and it's in the cloud API, in all cases, we have to start by understanding what we're trying to do. So step one is let's design our data store, right? So step one is let's design our data store. And a good way I found to do it is use an Excel sheet, because Excel is a very fast and light tool. They have more formal tools for designing databases. Excel has always done everything I've needed. Plus, I think we all have Excel. And as students, you guys all have a free license to Microsoft Office, right? Microsoft, if you sign up with your student ID, they'll give it to you. But if you're ever in a situation where you don't have Excel, I don't know, you're not a student and you can't afford a few $100s to buy it, you can always use OpenOffice as well, which is a freeware alternative. And it's getting quite popular. Because a lot of businesses, right, like imagine you have 1,000 people at the company, $300 a year for Microsoft Office, that's a lot of money. And it's open source, so there's security issues, right? Some people worry, they say, well, maybe Microsoft is putting secret trapdoors in their software to spy on us. Yeah, people say that. What you actually think you have that they want, I don't understand, but I've heard it. But the good advantage with open source products like Linux and OpenOffice is you can get your company's own build engineers to compile it and verify there's nothing funny going on with it. But for right now, let's go and start Excel. So work with me, please. Maybe on your lab test, I'll ask you to do this, so follow along. So design the data store for your college enrollment system database. And this is in the Dropbox, so if you want to get my version of it at the end, go for it. But I still suggest you follow along with your version. You put your hands on and go yourself. So what I did with my other class, and I'm not going to simplify it down that much because I guess you guys, you have all taken an introductory to SQL course. Yes, somebody type yes in the chat comment, just so I know where we're starting. Yeah? Jenna? Isha? Yes, you have, yeah, that's what I thought. Okay, so you're familiar with Codd's laws and so on, so we'll take it a bit faster here. So the basic concept is that all of this stuff, all of this SQL stuff came from a smart guy in 1973, IBM data scientist named Thomas Codd, and this is variously referred to as Codd's 12 laws and Codd's 13 laws. Who really knows? But anyway, the important parts of it are, Codd said a couple of things. He said that we organize data by topics, and we make topics into tables. Well, okay, I think I can, so far I'm not confused. I hope you're not either. So what concepts, what things might we have to deal with here in the college enrollment system? Well, we have students, and we have classes. So far, so good. And what fields might I need? Well, I could have a student name, and I know in the real world it could be first and last name, but for our little mock application here, I think this is good enough. So we'll just give our student one name like Joe or something. And students definitely need to have a student ID. Why do students need to have a student ID? Because Cod said, here's what he said. He said, guys, I mean, I wasn't there, but I'm guessing he probably said something similar to the following. He said to his followers, ladies and gentlemen, here's what I want you to do to organize data. Take any collection of data you have and figure out what the key topics of it are, and then figure out what designators you can use to describe those topics. And then you're going to make a table, and you're going to create rows in the table, and there will be one row for each unique record, and because it's unique, we must have the concept of unique identifier. And I hope your instructor in your database class beat on your head and got the concept into you that each row must have a primary key. Why? Because that's very important. If you do not have a primary key, you cannot do SQL. And if you do not have a primary key, then what do you have? Let's test how much you guys have seen here. What's it called when you... This sounds like a joke, but it's serious. What's it called when you do not have a primary key? What do we call the situation we're in when we don't have a primary key? Alicia? Chubby? Somebody just guess. You could say it's a mess. Yeah, well, it was a mess we fixed up. It used to be a mess till they invented this concept. The concept to describe the situation of no primary key is called what? Oh, Parth's going to tell us. Parth's the only one who knows. You should all know this. Well, yeah, we would have duplicate records, except we don't, but it's called big data. That's the answer we're looking for. Big data is a technology for managing data when you do not have a primary unique identifier for a record. Okay, Peter, when would I ever possibly not have a unique identifier for a record? Facial recognition, thumbprints, right? So imagine this situation here where you're busy and you ask your friend, you say, my mother is arriving in Toronto at the airport, and she doesn't know her way around too well. Could you go and pick her up? Because I'm working that day. You're a nice person. So you say, sure, I'll pick up your mom. No problem. What does she look like? And you go, well, she's not too tall and not too short, and she's a very cheerful person. Just look for somebody who's cheerful and happy. Now imagine how far you'd get at Toronto airport walking around asking random women, excuse me, ma'am, are you cheerful and happy? I'm looking for somebody. Security would bring you to a back room and ask why you're bothering people. So facial recognition is an example of where we do not have a primary key. Or another example in the business world, and some of you might wind up doing data analytics. I hope you do. It's a very well-paying job. And we want to correlate people's buying patterns to their web search history and then maybe demographic factors around them. So, for example, if I'm an advertising director and I have to promote a product, I will go and do research, and my research will tell me that this product would most appeal to women between 35 and 39 who live in downtown Toronto and they work in financial services sector. Why does it appeal to them? Well, we don't really know. We just know from the study, from having a lot of training data for our big data systems here, that people who have certain behaviors tend to do certain things. For example, interesting fact, when you one way we can have of determining somebody's credit rating, the credit rating, one factor they look at, if somebody owns a car and if they buy engine oil from like Canadian Tire or Walmart, then you say, well, how does buying engine oil make you a better credit rating? Well, because they say people who think ahead to take care of the car and keep it maintained are probably people with responsible behaviors who will pay their bills on time. So these are the kinds of correlations we look at to make in terms of data analytics and you cannot have a primary key there. And how we solve that is with big data, and we do not use COD's laws, because if you don't have a primary key, COD says, I'm out of here, I can't deal with you anymore. And that's going to be Mongo. When we get to our Mongo database next week, we will see how document collections can actually assist us with the case if we don't have a primary key. So it's either SQL, you have a primary key, student ID, class ID, or you don't have a primary key, then you have document collections, and then you have big data. So if you ever go to a job interview and they're asking you to explain, they say, Chabi, we ask our applicants some questions to see how technically knowledgeable they are. Can you explain the concept of big data? And Chabi's answer will be yes. If I have a data set and I cannot, for whatever reason, have a primary key, then I must use the methods of big data, which uses statistical analysis on document collections. Anyway, that's just a little bit of a warm-up into our session here. And there's COD's laws if you want to go and study them. And for that reason, we must have a student ID, because that's the primary key. And COD's laws, even though there are 13 laws, there is only 3 of them we really actually care about as working database developers. The other 10 laws are if you're going to build a database system by yourself. But we don't need them to use. Here's actually the 3 of COD's laws that we need on a working everyday basis. Number 1 is we must have a primary key. And that leads to number 2, which is we can now have normal forms. In our database classes, we talk about the first, second, and third, which are the only ones anybody ever uses, but professors have to be all academic and theoretical. There's 3 more normal forms that I've never actually seen used in the real world, but they relate to how we connect our data together. They relate to how we identify connections in the data, and if you do nothing except have a primary key, oh, I forgot there's one in the middle here. We have to normalize our tables, and this is very important. And these are not restrictions, these are enablers, because if you remember these rules as you're designing a database system, they will actually tell you how to structure the data. We must normalize our data. And the concept of normalization, and I'm sure you memorized very good definitions of it in your other studying, but the simplest way to consider it is that every other field in a table must have a one and only relationship to the primary key. So here's my primary key, and then every other field I have here must have a one and only relationship to the primary key. So normalization, this is not the strict academic theoretical definition, but it's a good practical working definition. Every record I'm allowed to put in a database must have a one and only relationship with the primary key. And I'll give you more examples to drill into that later. And normalization means I can only have, and somebody mentioned before in the comments about minimizing data and so on, and yeah, all of that stuff, minimization is another name for normalization. But everything you do, it just basically falls out of those principles, right? There are times when you don't have to have a primary key. I can take 2 or 3 or more columns and I can say that across these 2 or more columns, there must be a unique constraint, which means there must be a unique conjunction of data which can occur only one time in that entire table. But for right now, our main concept is every record in the database can relate only to that topic, can relate only to the primary key. So I have students and I have classes, so that must mean I have a class ID, and I can have a class name, and I can have a class room, although I guess these days it would be a class URL, and I can have a date time, and I can have an instructor. I could have other things probably, but those are the main things I need. Now, let's make an example here. So this is the kind of thing I might give you in a lab test. I might say create database records as follows. Or create database records to make the following scheduling SQL statement work. Because at the end, your 3-tier application, your web page, and your student sitting in front of it, they want to click a button and get their schedule. So their outcome is to get their schedule. So create database records which will have the following result. So Mary is going to be in Java 101 Monday morning. And class Earl, I'm just going to say class room, even though we don't have room these days. It's easier to think about rooms. And maybe in room 2. And then John, he wants to be in math 201 Friday AM in room 1. So what are all the things we would need to do to make that happen? Well, because this is not, if this was a database class, I'd make you do this by yourself, but I assume you already know it. So I'm just going to quickly fast forward ahead so we can get to the point of connecting to SQLite in Node and actually making the stuff happen under program control. And then round tripping it to the front end, to the web form, so we can display all this stuff through the web interface on an Express server. Well, I need to put some data in here, and now Excel is pretty good because Excel is it's a nice tool for letting us quickly mock up and prototype data. So I'm going to make some student records here, and I'm going to say student 101, and that's Mary. And then student 102, and that's John. And now what about classes? Well, over here I could have, I'll just call my class ID Java 101. We'll say that's a good enough class ID, and Math 201. And then the class name, again, we'll just call it Intro to Java or something. And we'll call this Math for Business. All right. So now here's our first problem. How am I going to construct a data structure which is going to let me generate? See, I want to generate this schedule, right? The goal is click a button on the web form and this schedule will be presented by our system. This data set, this data grid should be presented by our system, by our database. Does anybody have any idea how I'm going to do that? Oh, I know. Wait a minute. Why can't I just put class information over here in students? Am I allowed to do that? Can I put class information in students? Guys, this is pivotal and foundational. I have found out for many years of doing this, if you do not understand this right now, it's going to be like a little sticky thing that'll impede your learning further on. Well, Tatiana, actually no, you cannot do it. Why can't you do it? Because that would violate normalization. Right? You cannot do what I just did. And that's why I'm going through this exercise, because I'm sure you were exposed to this, but we might need to freshen ourselves up here a bit. So putting class ID here, see, I can have Mary, and Mary has a one and only relationship to her student ID. See, that's one and only. Mary is the only student 101 we're ever going to have in all of history. In all of the past and all of the future ages in college, each student ID is completely unique. So far, Dr. Cod is not mad at me. And my wife says, don't speak badly about dead people. They'll come and haunt you in your sleep. So I don't know about you. I don't want to mess up his Cod's 13 laws. I'm kind of superstitious that way. I don't want to wake up in the middle of the night with his ghostly presence. Peter, you're violating normality. We discussed this. So we don't want to do that. Does everybody understand why putting class ID in the students' table would be a bad idea? Because how many classes does a student take? 6, I think, right? So that means I would need to have 6 records for Mary and 6 records for John. And if I have 3,000 students here at college, I need to have, 18,000 records. And then imagine one student gets married and changes their name. Maybe John Smith gets married to Susan Jones, and he takes her last name or something. Yeah, they tell me guys do that now. To be progressive, they take the wife's last name. So anyway, you get that situation, right? Because one of the big reasons why COD was so hard on this normalization thing is in the early 70s, everybody started getting computers and everything started getting computerized, and the world was drowning in data. The way they stored data back then was on magnetic tapes, and if you wanted to find a record, you had to walk through them one at a time, And you wrote COBOL to do that. They were called data frames on the magnetic tape, and there's actually still in COBOL, even though nobody has used magnetic tape in generations, there still is a procedure in COBOL for searching record by record on magnetic tape. And when you had 100 records, you could do that. When you had 10 million records, you cannot do it. So no, the bottom line of the story is we're not allowed to put class there, because then I would duplicate the class information times each student. So no, Tatiana, sorry, but you're completely incorrect there. Oh, wait a minute. I have a solution. I'm going to put student ID over here, and then... Oh, no, I can't do that either, can I? Because for each class, I have 40 students, and then instead of just having 1 record per class, I'm going to have 40 records per class. Guys, sorry, something's going wrong with this lab. I'm not sure what's going on here. I don't think we can do this. I don't think there's a way in SQL to solve this problem of creating a schedule for students. Can anybody think of one? Ah, Kapil got it. Very good. So Kapil has twigged on the fact that we are in the relational database management system. And whenever I'm at college, when I'm teaching in the room, I always look at the guys when I say that, because men do not have a good concept. When you mention relationships, they think, oh, there goes my freedom. Well, no, it's not that kind of a relationship. There's no emotional drama here. However, Kapil is, and all the rest of you who said it are absolutely right. We make another table, and in fact, we can call this whatever you want. I'm going to call it the enrollments table. And why are we dragging this out? Because I think some of you need it, right? I think it's probably basic truths bear repeating, they say. So let's make something here called enrollments. Oh, wait a minute. I just thought of another problem. This is not going well for me, is it? Because I had a student ID, because students have a student ID, and I had a class ID because I had a classes have class IDs. How can I have a unique enrollment for a student? How can I have a unique ID for an enrollment record? How can I have a unique ID for an because student I knew was student ID and class I know is class ID. Well, how am I gonna handle enrollment, do you think? You make, well, actually, yeah. Yeah, Kapil said you could make it an aggregate. You could do that. We could. That would be fine. That would not, COD is not going to come and haunt your dreams because you're respecting his rules, but it's more complicated than it needs to be. We can just make one up. See, we can make one up here. We can call it enrollment ID. And why I'm dragging this out a bit is because some students, they get stuck on this, right? And you need to understand there are two kinds of tables here in relational database land, and they are, we can have model tables which model things in the real world, right? A student's an actual thing. It passes the smack test, right? If you smack it, it makes a noise. When we're together at college, I ask everybody to slap their people beside them, and then the student goes, ow. We say, yeah, they passed the smack test. So you can have actual real things, but you don't have to. You can also have relationship tables. So you can have modeling tables, which model things that actually exist. You can also have relator tables, and that's the relational data. That's why we call it the relational database system, relator tables. It's not a real thing, but it is kind of. It's a relationship. That's still a real thing. And here you can just make it up because COD did not say that the unique ID, you see, you have to be like a lawyer. To be a good IT person, you have to be like a lawyer, and you have to study the exact meaning of words. And COD did not say the primary key has to be meaningful. All he said is it has to be unique. So I can start with 1, 2, 3, 4 and work my way up. And in fact, we're going to see in SQLite and all other database systems, the database actually gives you a way to do that, right? It gives you a way to auto increment. Now, I have not found, and I sort of think it should exist, but I haven't found it anywhere. I have not found a way to auto increment primary keys under program control. So the way I do it is I just do a SQL pull, right? It's easy. You can just do a SQL pull in your table on your primary key field, and you can use the SQL function max. You can find the maximum thing. So if the maximum enrollment ID is 1452, I just add 1 to it, and I say that's my next one. So, and I'm sure there must be a more elegant way. I've just never found it. If any of you guys find it, let me know. So now, if we want to put Mary into Java, here's what we need to do. So we need to have enrollment ID and student ID and class ID. And then you enroll students or you remove students. You can take them out as well by adding and removing record from the enrollment table. And that is massively efficient, right? One of the great things about SQL, it can handle 100 million records, no problem, because it's optimized. SQL is a programming language, and it's a declarative programming language, right? That was one of the questions in your warm-up quiz this morning. I do not tell the SQL compiler how to do the work. I just say this is what I want, select star from students, and it has optimization routes. And there's a whole branch of computer science related to how you optimize SQL data searches. We're not going to get into it here, but if you go to university and study theoretical information science, that's a very good field, right? If any of you guys have the concept that maybe you want to go and take some advanced education, a lot of my students go to University of Manitoba, I guess. I don't know, maybe they like it there or something. But they go and they say, Peter, what should I study? I say study data analytics. Data analytics is the gold rush of the 21st century. But we're going to introduce as much as that if we can here in the constraints of our time. So enrollment ID 1. Why is it 1? Well, I don't know, make it 1492 if you like. It doesn't matter. It just matters that it's unique And now my student ID for Mary is 101, and she wants to be in class Java 101. And that's my first record. And then let's take care of John over here. We don't want him to feel left out. And we're actually going to go over right now. And why I drag this out is because if you present a multi-part technical activity, and if somebody does not have insight into one part, that confusion is going to sort of diffuse over into the rest of the environment. And you would have trouble perhaps locking into the concept of how we're manipulating the database with SQL if you did not really, down to the bone, you didn't get at what's going on with the SQL. So I think this was a good use of, we didn't spend too much time, maybe 20 minutes, but I think it was a good use of time. So here we have enrollment 2, and we have student, who's John again, he's 102. And he's looking at a career in math, so we'll say his course code is Math 201. So now let's actually go and make this happen. And I'm not going to go over this again. You guys will have more complicated requirements, but I've recorded this as well, right? So you can always go back and watch the video, and you have the spreadsheet in your Dropbox directory. So let's fire up DB Browser for SQLite and make this happen. So we have 3 tables we need to bring to life here. So DB Browser for SQLite. Let me just check to make sure we're all still in the meeting. Yeah, Kapil, you could use the timestamp, but I'm going to tell you one thing. If you actually work as a database administrator, which is an IT person, it's likely you might at some point, especially in the junior years when you're getting started, they might move you to different sections of the company so you get familiar with all ends of the product. It is much easier. If I'm troubleshooting a problem, I would rather describe it to somebody else by saying it's enrollment record whose unique ID is 1452, rather than its timestamp is June the 22nd, 2021 at 14:52 and 3 seconds Eastern Standard. That would be awkward. It's easier to just have a number. I mean, you're right. It could be anything unique, but I'm just thinking what actually plays in the real world. All right, I got a couple of comments coming in here. Well, I'll come back to the comments in a minute. If you're typing, oh yeah, so I'll get back to you in a minute. So you guys should be able to do this yourself. I think it's a pretty simple tool. So first of all, we want to make a table. So we say create table, and it's called students. Oh, so I have to say new database first. Everything in SQL you can do with SQL. And you probably know, I'm not sure if it was on your test this morning, there are 3 kinds of, I mean, I don't want to call them different languages. There's 3 formulations of SQL, right? There is DDL, data definition language, and DML, data manipulation language, and data security language, I forget, oh, data control language, DCL. We're not going to deal with the control, we're not even dealing with security. That would be a 14-week course by itself. But data manipulation, data query language, DQL, that is select, right, insert, update, that's CRUD, create, read, update, delete. And then the other way we can do SQL is to actually create, so that one, data query language deals with creating and changing and deleting data records. So that's data query language. Then we have DCL, data control language, and that deals with creating, changing, deleting tables, fields and tables, and schemas and other things as well. So you could actually create tables under program control. You're just dispatching SQL. It's not hard. I've never actually seen that done. Generally, you start seeding your data, you know, seed like you put an apple seed in the ground to plant a tree or something. You seed the data by creating it with a tool like this, and then you use your program code to do the the query manipulation to do the creating and removing of records and stuff. Anyway, so let's go and create a new database, and I'm going to call mine CIS for College Enrollment System. Note here, and that was from when I did it in a previous class before, it is just a file on the file system, right? It's just a file. It saves to the file system. We open it from the file system. It expands to life like, like powdered mashed potatoes. You just boil water and you put these flakes in the bowl and you stir them around and add salt and milk. Then you have mashed potatoes in a few minutes. So this is like freeze-dried food. You're freeze-drying your data down to the file system, and then you're sucking it into your program, and it's inflating like air in a balloon. Then you get all the data back. So I'm going to save this in your lab directory. You guys want to go, you should follow along with me, but if you want to refer to my one later on, it's there. So call it whatever you want. I'll just call mine CIS for College Enrollment System, and the extension will be .db, so I'll say save. And now it wants a table here, so my table is going to be students, and I suggest you keep everything lowercase, because SQL is case sensitive, and so you don't want to forget or like have a query mess up because you called it uppercase here and lowercase somewhere else. Now we'll add fields. So we'll say add student ID, and I'm keeping it all lowercase. And I'm going to call it text. And I always get students who challenge me on that. They say, Peter, shouldn't it be numeric? My rule, well, it's your database. Do whatever you like. My rule is unless I'm going to be doing math on something, like maybe it's GPA, and I want to grab their marks and calculate their average or something, then you want it to be a number. In general, I'd say if you don't have a big reason to do something else, make it text. Because right now, maybe all of the student IDs are just numbers, but maybe tomorrow the college is going to change their mind. They're going to say, let's start putting this letter C in front of all the student numbers, and then you need to go and migrate all your data. So just in the interest of future changes, just keep it text. Now, we do want this to be a primary key. And I'm going to say AI for auto increment. Auto increment, right? That's the thing we said. Every time it creates a record, the database engine will be in charge of grabbing the previous highest number and just throwing one more on it and getting it up there. And that's about all we need for right now, I think. Now notice down here, it's actually generating the SQL that it's going to use. And another thing this is nice for, if you're doing your programming and you need a SQL statement because you have to put the SQL statement in the code, you can always jump out here. Sometimes I just use this as a quick way of generating a SQL expression for using somewhere else. So that's all standard ANSI 77, American National Standards Association. SQL is an international standard, and if you desire to be an IT person, there's a couple of things you should read. One is COD's 13 Laws paper, or maybe it's COD's 12 Laws. Anyway, Google it and you'll find it. And you should also read the SQL specification, right? There's about 6 papers we never teach students about, but if I was in charge of the world, I'd make you study that stuff. So anyway, there's the auto increment thing. There's what's making it a primary key, and there's the field name and the field type. So now we're going to go here, and we want another field, which is student name. So we'll say add field, student name. And this is generating a starter SQLite database that we're going to be manipulating in Node in a few minutes. So student name. And that'll be text. Oh, why did student ID wind up as integer? I wanted that to be text. See it, update it down here. And student name is text. And I'm not giving any special qualifications to that. Now you could go and put more stuff here. You could put their cell phone number or something if you want. Go for it. I'm just going for the minimal viable product, the MVP, the minimal thing that it takes to get this up and working for us. And you can modify it later as well, right? If you need, you can change it later. So that should be good enough for that. So now we will say OK. Error creating table. Auto increment is only allowed. Oh, yeah, that's right. I could only. So that's why I made it an. All right, just make it an integer since you want it to be auto increment. All right, we'll just tell the office the student ID has to be. Now, here's another thing you could do, and I've seen this done. If a student ID follows a certain format, but you still want, you can make up your own primary key separate from the student ID. There is no law that says the primary key has to be the student ID. In fact, that's probably a better way to do it because in general, student IDs, I don't know how they assign them. Maybe they have some schema that I'm not aware of. So I'm not going to use student ID as my primary key. I'm going to have student ID there because students need to have IDs. But I'm going to make my... Can I edit this directly? Oh, no, I can't. All right. So I'm not going to make that my primary key. I'm just going to make another primary key called... just call it P key. You have to be careful when you're coming up with variable names not to make it something which could be a SQL reserved word, but I'll just call it P key. And this I'll make auto increment, and this I'll make my primary key. And that's a design decision. That's just based on experience because I don't want to make my database design tied up to what the office is going to do in terms of their rules for assigning product code. And you guys probably don't like to think of yourselves as product, but yeah, your products and your student ID is your product code. So I want to decouple those two things. So I'll do it this way. And that's not going to hurt me because I can still assign their student ID and I can make it text and I can let the database to be in charge of the primary key. So we'll click on OK. And that should be it. Now, next we need to put data there, but we're not going to use this tool to insert data. We're going to use Node.js to insert data. So I have one table, which is students. Why is it saying I have two? Oh, SQL sequence. Yeah, the SQL sequence, that's just something that SQL maintains internally for its own housekeeping. Don't change it. Don't delete it. It has nothing to do with your life. The database is using that for its own internal maintenance structure. So now let's make our enrollments table. So we say create table, and we say enrollments. And that's going to be enrollment ID. And here, enrollment ID is something that only exists in the context of my database. Nobody else in the world is ever going to care about it or have any opinions about it. So here I can just go and make this my primary key and let the database be in charge of it. I'm never going to use that for anything. It just has to be there to keep Cod to shut him up so he stays happy. Sorry. No disrespect intended. Enrollment ID. Keep everything lowercase. And that can be integer and its primary key auto increment. And then what I do need is student ID and class ID. So student ID. And yeah, we'll make that text. And class ID. And make that text. And finally, we want one more table, which is our classes table. So let's go and do that. So just work ahead and do what you know what to do. So create table classes. And we have class ID. That's going to be a primary key. Now it's the same thing. The college is telling me that it is Java 101, but I don't want to tie up my primary key to that. So I'm going to have something here called p key per primary key, and that'll be an integer auto increment. And now I'll have the class ID, and the office can do whatever that wants, because now my design is decoupled from their business decisions. And that will make text. And we'll have class name. Actually, I'm breaking my own rule about keeping everything lowercase. And that's going to be text. Now, you don't have to use a GUI tool to change the design of the structure of your database. You can just use data definition language, and you can go, there's all sorts of online resources. The one I like is W3 Schools. Their SQL documentation is great. It gets the information quickly for you. And then we have room. Actually, I don't really care. I could put in room. I could add it in later, but I don't really care too much about it, because all I want to do right now is generate this schedule. And actually, yeah, the schedule does say room, so I need room. Okay, so let's go and put room in. So we have classes, class name, class room, and date, time, and instructor. Date, time, and instructor. Actually, I don't really, I'm going to save time. I don't care about the instructor right now because it's not on the schedule. All right. And there's our SQL statement that's going to make all of that happen. And actually, let's make the date time to be, actually, they don't give you a date time. Actual SQLite. Yeah, SQLite's a bit limited. Like other databases you've worked with, such as MS SQL Server, will give you date time as a data type, and then you can actually use SQL functionality like calculate the number of days between two dates. But anyway, we don't care about that right now. So we now have a table, and our next step is going to be to write some Node.js code, and we're going to start inserting data programmatically. We're not going to use the GUI tool because we're programmers. That's what we do. So now let's go here. I'm going to close all of this stuff out.